Thanks for coming. Anyone joining? Wanted to first welcome Yuri to the show. We're having a great time. We're going to show off a cool project that I think is really neat for people that need to do HA and kind of global Kubernetes deployments. And I think it's a really neat idea for how people are able to kind of deploy their apps. So let's go ahead and actually start. Yuri, go ahead and give it an intro. And I actually wanted to mention just a couple things to it. Wait, we're still going? What? What happened? I don't know. I saw some chat. I think we're okay.
All good?
Yeah, Yuri, go ahead. Give us an intro.
Yeah, hey guys. So I'm Yuri. I work as a principal engineer in APSA. APSA Group is a financial organization in Africa. We are serving 11 countries on a continent, and we have a pretty huge scale, and we are trying to obviously running our services as reliable as possible. So usually our workloads span over multiple data centers, usually deployed in pair. And we obviously have a challenge to create global load balancing strategies in an automated way. So that's how this project was created. The k8gb project, it is a fully open source global service load balancing solution, which is cloud native and Kubernetes native. So APSA was trying to solve this problem with several vendors, but none of them were working for us like in a Kubernetes way. And the main goal of the project not only to be able to steer the traffic in a global manner, but also to provide an application development teams to fully control the global strategies from their side, utilizing Kubernetes API abstraction power. So with a single CRD controlling the global balancing scenario. So that's roughly the goal.
That's a great overview. And I want to dig into some of those specifics in just a minute. I did want to talk, just anyone that's on the stream or watching the video, just last week, EKS team had a pretty big push for speeding up EKS cluster deployments. And I drop in the link to the announcements. I did want to talk about, because I know there was some confusion around this announcement and just kind of like what it did for people using EKS clusters. The average for a cluster creation should be around 40% faster than it used to be before last week. Go ahead and read it. I did want to just mention real quick that there is some differences between what a EKS cluster is to some people and what a fully deployed with workers, with VPC, with load balancers, with everything else. And so I just wanted to call that out as if anyone has questions around this or sees something drastically different with EKS cluster creation, go ahead and let us know. Hit us up, on Twitter, whatever, chat in the show. It's a great thing that I think is we're moving towards getting clusters faster to people, but I just wanted to point it out as there might be some confusion on hey, I ran EKS control and create cluster, and it might have been longer than 9 minutes of the average that we claimed. So just wanted to call it out. It is still faster, but there's a lot of components of EKS cluster. The control plane, way faster. Cloud formation, VPCs, security groups, load balancers, worker nodes. There's a lot that goes into a complete EKS cluster. So I just want to call that out.
I'm pretty sure some APSA guys complained after this announcement that it took 11 minutes for us instead of 9.
It's great. You should be seeing faster times no matter what. The average faster time should be better. But I want to, because it was a huge achievement for us to be able to speed that up. But yeah, if you're seeing 11 minutes versus 9 minutes, that might be why. Ephemeral clusters coming soon. 121 release. I'm trying to remember if ephemeral clusters, yes. I'm thinking ephemeral pods. I'm very excited for the 121 release coming out next month. I've been on the release team for 121, and so working on seeing what new enhancements are coming out, what's graduating from either alpha to beta or beta to GA inside the API is great. And so ephemeral pods was one that I was super excited about for debugging. So, but ephemeral clusters, yeah. Let's get a cluster. If you can get it within a few minutes and try something and then throw it away, that's literally the sort of use cases for just trying things in the cloud. And that's how I originally learned Kubernetes. I just spun up a cluster at my lunch break, tried some things with API, threw it away, and it cost me pennies on the month. And it was great. So highly encouraged. But it's not exactly what we want to talk about here. And I want to dig into some of the things that your team was solving for your deployments with Kubernetes, where you had global deployments that you mentioned are usually synchronized around whatever clusters. So you're not doing necessarily like weighted clusters or GeoIP routing, but you do have a lot of need to be able to make these things highly available across clusters around the globe.
Yeah, exactly. So our current main use cases were like just a couple of simple strategies like failover and round robin, and advanced stuff like geolocality is like a next step. But currently we have like our teams are pretty satisfied with this like simple, easy to understand the strategies. So the more advanced one are coming most probably like from a community standpoint.
Yeah, and that makes sense. I mean, when you're starting with any load balancing, start with, I need something that's, failover where like something went down, don't make me have a lot of downtime. And the other is just general load balancing. I was just saying like, hey, just send this traffic to both places. It's a hot scenario of clusters and deployments. I also thought go.
Apple's gone.
I just love your approach of making as much as possible Kubernetes native and then DNS, where people don't have to adopt full application meshes. They don't have to adopt special load balancers with different unique configs. At the end of the day, this works in AWS, but also in other clusters because it's DNS and it's using external DNS to kind of make those records and then owning a top level domain for its routes.
Yeah, there are a couple of things to that. So one thing that I think strongly differentiates k8gb from another solutions, even some open source ones, that we do not have a control cluster. So k8gb controller is getting installed on all target clusters where it is about to enable global load balancing for workloads that are sitting there. And there is no single point of failure, like there is no control cluster instance which would break things assuming it's down, right? So and the k8gb operator instances are syncing state with each other, also over reliable DNS protocol. So we getting rid of a whole class of problem like mutual API authentication, certificate rotation, all of that things. So it's intentionally very simple and relies on a battle-tested protocol. And another thing to that, like a naive approach would be to create DNS entries with external DNS as being an integral component of k8gb, to create this DNS right in a target DNS environment, like Route 53 or NS1 or Infoblocks. That's the three, by the way, DNS providers that we currently support. But we are not doing it. Instead, we are running CoreDNS instances as an integral part, another part of a k8gb solution, which are residing right on the clusters, and they are serving the actual DNS responses, the DNS requests, sorry. And producing the DNS responses. And what is configured in automated way in a environment DNS provider, for example, Route 53, it's only automated zone delegation, which is automatically configures the so-called HDNS zone and basically steering the DNS queries to the target GSLB enabled clusters. So this way we are able to test the solution in isolation and make it as much environment agnostic as possible.
Yeah, and I want to dig into that a little more. And I'm such a visual learner. I'm gonna pull up my whiteboard here so that I can kind of show an example of how the components work together and how I see them. Let me see. Wait, I got that branding logo over the top. Did I switch it? No, I had to do it twice every time. One sec. There it goes. All right. So I wanted to just high level overview, and we're going to get into a demo for anyone watching real quick on this actually in action. But to me, I really have to visualize the components of it. Of like, I need to understand what's doing what, and why is it important that it's there, because that's just how I kind of work. So let's just start with, we have 2 clusters here, and then my pen stops working. There we go. 2 clusters. We have, oh, I can't. It's so laggy with the screen share. Oh, I didn't think of that. Okay. Cluster 1 and cluster 2. And this is where all of our workloads are existing. These are different regions. We're able to deploy applications, and you mentioned your use case is essentially you mirror these clusters. There's nothing special about one or another. There's no larger scale or like only certain apps. So this is a great use case if you want HA or disaster recovery in essentially equal clusters, right?
Yeah, that's pretty much set up, yes.
And then somewhere out here, we have our actual external, man, this is great lag for me. I'm like so delayed with the write. But here's here's Route 53, okay? This is our external DNS. And this is a global resource. So this exists outside of the clusters. Anything can point to this, which is super helpful for this sort of, I need a load balance, and this is a great way to use DNS, right? Like, Route 53 has 100% uptime. We have the ability to see that across the world as long as DNS propagation and the normal protocolness of DNS works for us. So what k8gb does is it's going to actually work in conjunction with a external DNS provider. So each cluster is going to have the external DNS. Oh, pen. I have to do it with my mouse. Why does my pen stop? Anyway, this external DNS piece is going to manage our Route 53 entries. But as you mentioned, it's not making these one for one with an internal, like, I need this service exposed. It's exposing this so that the k8gb controller can actually do the namespace delegation, right?
Exactly. So it just zone delegation creation, and zone delegation incorporates the CoreDNS instances IP addresses of the target clusters. So effectively, depending on the environment, in AWS, it will be 2 network load balancers that are exposing 53 UDP port of effectively CoreDNS pods. So
yeah,
it will
and
be
that
propagated.
I think that's really unique. By basically, we're taking I have, so like in my example, I hope I can actually write this out, but I have test.k8gb. I have that domain in Route 53. That is what actually gets pointed to these 2 instances, and then those are managing every other subdomain above that. Just making sure.
Yeah, whatever goes before test, so next level domain is going to be served by k8gb CoreDNS instance.
And that resolves to services and ingress inside the cluster itself. So k8gb is going to look at, okay, everything that, if I have a x.test, that is going to resolve to something inside the cluster here, not necessarily like I'm not exposing that directly, but by allowing k8gb to take control of that subdomain, that's where the actual failover and round robin and different strategies takes into effect.
Exactly. So k8gb relies on this special CRD we'll probably demonstrate further, where the CRD is a kind of GSLB which incorporates the ingress resource and a load balancing strategy. So everything is CRD controlled, and effectively whatever is mentioned in ingress host rule will be automatically resolvable, assuming the underlying workload is healthy. So like pods are running. So that's another actually important point of a k8gb design. We intentionally we are not relying on a standard load balancing classic HTTP checks, which are very end-to-end, right? Nothing is passing traffic through itself. There is no dedicated k8gb instance. So instead, it's just DNS-based traffic steering, and health status is determined via classic core Kubernetes primitives. So it's basically down to standard pod liveness and readiness props. So effectively, it looks on through this chain. It's ingress, then associated reference service, and the service has a endpoint array, right? So if endpoint array is more than 0, then at least one. It means transitively that at least one pod is healthy. So that k8gb will treat this workload in a healthy status, and will return the associated response. And that's another point to enable application teams to drive this balancing strategy and incorporate the props that they think make sense for their workload, right? So it's flexible on a pod probe level.
Yeah, and just calling out Kobushan, wrong one. Kobushan's question here about, can you change the actual algorithm for load balancing? And you mentioned earlier, yes, right now it supports either failover or round robin. Round robin is also assuming that the two clusters are equal, with I have an equal number of IPs, which is just essentially a random allocation based on however many IPs are in each cluster. So if you have a 3AZ cluster, in each region, you're going to have 6 IPs, and round robin is going to pick 1 out of 6. So at least, you might get 3 in a row go to one side, but eventually it's going to be round robin the DNS. And then the second strategy is failover, where if one cluster goes down and says, oh, I don't have any endpoints, it'll update DNS, and DNS will propagate, and then we'll see that in the actual dig requests.
Another one.
Yeah, and I know you mentioned earlier you wanted, next steps for you are IP locality, where, hey, who's requesting this? Can we route it to the closest cluster based on the IP address? I think those are, there's plenty of ways to extend that. I think starting with hot clusters and then a hot cold cluster are great strategies for anyone to I just need something highly available. What can I do?
Yeah, and currently we basically operating, we dynamically constructing the DNS endpoint CRDs in the backend. So that's how, and this the information is so CoreDNS reads the DNS endpoint CRD and returns the associated response, right? So that's how k8gb controller populates this information into underlying CRDs that is even not exposed to the user, right? So it's like internal mechanics. And so currently it's based on composition purely. And so it's not very dynamic. Meanwhile, it brings us a capability to create these simple strategies of failover and round robin. And when we go to the next level, like load balancing algorithms like geolocality or consistent round robin, where it will be balancing between 2 or more geographic location in a consistent, reliable way. So making 50-50 in case of 2 clusters, 50-50 traffic split. Then we will have to actually hook into CoreDNS level with some advanced plugins there. So it's it's a next iteration of the projects that we are planning. We already have in a roadmap. So yeah, whatever goes more advanced than a simple composition, we will have to extend CoreDNS itself to make more dynamic responses in our runtime.
I know that's actually a really interesting piece about CoreDNS is it has plugins. It has this ability to extend it, which might be a little different than older, bind or whatever. To extend it with custom scripts and things is a little more fragile. So CoreDNS was intended to be extended like this. I guess even then, CoreDNS was created originally from what was the web server, Caddy. Caddy, hey, we can make that a DNS server, and then DNS, it was amazing just to see how that project kind of progressed into this thing that's critical for Kubernetes clusters now. The last piece I did want to point out here was just kind of the components that k8gb requires or installs in the cluster. And for a lot of people, like ingress is a given. You're going to have some way to get information in and out. I know there's lots of different like ingress routes. There's service mesh is going to have north-south traffic. There's Contour has, I forget what I think they're moving to ingress route, but I forget what they had originally. So there's a lot of ways to get traffic in and out. In our demo, we're using the Nginx ingress controller so that we can just show off like, hey, here's some examples. The k8gb controller is the actual like endpoints inside the cluster. API, the new Ingress v2. That's right, Ingress v2 is coming out. Man, there's so many ways to get traffic in and out, which grew. I'm gonna pull that. Which grew exactly from Ingress was in beta for so long, and so many people relied on it. We had to find good ways to extend this to make it usable for everyone, and not just in these like custom annotations on Ingress controllers. It was getting really difficult to, which feature is available where. So kind of compressing those down into like the basics, and then everyone can kind of actually build on a standard. I think it's important. But back to these components, and then external DNS is actually like take these entry or take at least the NS records and the GSLB endpoints and put those in my external DNS so that they route for namespace delegation into these 2 pods or whatever, the pods in each cluster, to be able to then resolve names. So it kind of goes around, but like your services are going to be here on Ingress, and then your DNS requests are going to come here to the k8gb controllers. So I hope.
Well, just to be completely precise, so k8gb controller is like an operator which automates all the things happening, right? And CoreDNS are separate pods, so they are talking to each other. Like basically, CoreDNS reads from DNS endpoint CRD. So I dropped you in the chat, and customers are getting exposed to GSLB kind, right? So
right, there is that other CoreDNS piece here that k8gb brings along with it. This is different than the cluster CoreDNS for service discovery inside of it. This is, that's right. This is CoreDNS for the actual global routing of the endpoints. Good call. So
one additional thing while we are on CoreDNS and a pluggability of it. So before we were running like a standard special external DNS, which was working in a local scenario to propagate the DNS records to be available for CoreDNS. It's a little bit, there was like an amount of confusion there because it was kind of external DNS for a local cluster state. And the thing is, it was standard documented approach on an external DNS project, how to propagate the entries for CoreDNS. And in this scenario, we had to deploy standalone etcd cluster. So basically, it was SkyDNS, and CoreDNS was reading from etcd cluster. So we were facing with this setup. It was working, but on long running clusters, and we faced reliability issues. So it was like a combination of etcd and etcd operator, which unfortunately already not maintained. So, and it's too many moving pieces. Anyway, right? Dedicated etcd cluster already kind of doesn't look good, right? So, so we recently implemented CoreDNS plugin, which is capable, which actually enables CoreDNS to read information right from Kubernetes CRD, DNS endpoint. So we basically skipped whole etcd dense and managed to deprecate it. So much less moving parts. So it made whole setup much more reliable.
Well, and you're using the Kubernetes API, which is already etcd on the back end for the data that exists there. Yeah, it makes sense. And it actually, like when I first deployed Kubernetes clusters I was doing it on container Linux or CoreOS Linux, and CoreOS comes with an etcd for for the cluster itself, for the machines to know how to do updates. And I remember like just standing up another etcd was like, oh, this is kind of difficult. Let me just use the one that they already have. And so like I literally like I had the one for the operating system to coordinate how they were doing updates. I'm like, I'll just throw all the Kubernetes stuff in there too. So I had Kubernetes on top of that, and then I was using SkyDNS too because it was early on. I'm like, oh, just throw that in the CoreDNS I already have. It was bad idea. Don't do that. Like I just kept reusing the same thing over and over again, but not going through the Kubernetes API. Like, oh, let's just make the etcd calls directly, and like that's how I was kind of learning how these pieces fit together and like why they were needed and what it was doing. So I don't recommend it, but yeah. Now things are a lot more simple with everyone using the Kubernetes etcd, database through the Kubernetes API as CRDs, the way it's intended to be used, gives a lot more just like RBAC and, there's so many benefits around just doing it the right way. And so, yeah, using CRDs directly is great. So I wanted to show off here what I have set up essentially, and control cluster. Actually, I have two different clusters. One is US East. That my left pane is US East, and my right pane is US West or EU West. Oh, that's not what I wanted. And I think my East cluster was larger, and I don't remember why, but it is. So that's how things are set up, but everything in both clusters, as we said at the beginning, is essentially identical with the deployments with regards to like how that's being used. And so let's start here with just showing some of these components again. And I have pause. Is it Nginx ingress or ingress Nginx? I always forget. Get it backwards no matter what.
Ingress dash.
Yeah, it's ingress first. Don't complete it. So I already have my ingress controller set up here. It's there, it's running. I have a service for it. It has a load balancer. So that's already exposed, available in the cluster. And then I have these namespaces for k8gb. So I have a k8gb, which is actually the controller itself. And then I have this test GSLB for the global load balancer for where I actually have one test application with some ingress rules and services. But if I look at pause, we can see, again, this is the same on both clusters. We'll see those pods that we were talking about where we have the k8gb, we have the k8gb CoreDNS, and then we have this external DNS, which is actually responsible for creating these endpoint rules in my Route 53 namespace. So I know I could even like zone, there it is. So if I look at my records in my Route 53, I can see I have, here we go. These records for where those endpoints are, and I'm using this test k8gb jgar.net. Well, I guess it's actually here. With the subdomains are allocated to k8gb and saying that, hey, you own that after the test inside of CoreDNS or inside of Route 53. I'm getting so confused with all these DNS entries in here. But after the test subdomain, everything after that is up to k8gb to resolve and manage. And then also just want to show off a couple pieces here. Like I learned a lot setting this up with just using dig, because it was just the standard way. Like, let's troubleshoot. Do we have endpoints for this? Where does this resolve? Where are my IPs? And I can line up where those, the short TTL pros and cons there. My mouse I see my mouse in the video and then I don't see it down here. The short TTL is important for failover, right? Because like if I want it to fail over quickly, I need a short TTL, but it's bad for load. And so you have to find that balance for your clusters. If you're like, oh, how fast does this need to fail over versus how much load can this handle based on how much traffic you're getting or lookups. So it's up to you to kind of understand how that works. And it, again, it's DNS, so it's like the answer and reason for all of our problems in technology. It just so happens to be the like core fundamental piece in so many ways, but also like if you don't understand it or you set something else up wrong, TTL 0. Yeah, thanks, Brent. Just let's just roll with that. Yeah, it'll fail over faster. No problems will ever happen there. But so let's look at let's look at my let's look at the failover first. So here's where my service, oh, and actually let me show off my ingress too. But I look at this failover endpoint inside of DNS 3. Did I scale that to 0 somewhere?
One cluster, right?
I thought I had it in 2 already. I have to look. Maybe I scaled it down and I forgot. So this is, again, like I was doing so much troubleshooting beforehand of like testing, scale down, scale up. And yeah, 2 clusters, but each one is 3 AZs. So I should have 6 endpoints there.
No, it's failover. It's not round robin, right?
Oh, right.
Yeah, it should return only 1 cluster. Yeah.
Right. If I do round robin, oh, that was 4. That was the sync we were having a problem. I was having a problem with one of my new load balancer getting in there. But you're right. Failover is only pointed to 1 cluster at a time. Round robin should point to all of the clusters or all of the endpoints wherever it's going. So yes, my round robin strategy for DNS is going to be different. But inside the cluster itself, it's standard ingress. Like I have just standard ingress exposing where these applications are, and here's my failover, and here's my round robin. And if you want to try this out yourself, go look at the k8gb repo. There's make targets for all of this. It makes it so easy to kind of make a cluster, make ingress, make all these things inside your cluster. You can try it yourself. We're going to demo walking through it ourselves. So if I look at this failover, get GSLB. These are the CRD that k8gb is going to create, and I can see one here. And here we can see that my failover right now is set. My geotag is US East 1. I'll look at this in my EU West cluster as well, just to make sure that it's synced up, but I should have those records essentially the same. And if I, in this cluster in US East 1, scale this down to 0, DNS will propagate, go into those GSLB or the core DNS behind GSLB endpoints, and I will get the new IP addresses serving this traffic. So let me just verify that. Again, it's identical, so I'm in this different cluster, but using the same command here. And this is the one that has the 1 endpoint with a different geotag. Now I'm curious if I did something wrong still. Let's check. Let's look at this.
If it has 1 IP address and probably current load balancer results to 1 IP address, that's what it does for in the background, right? Whatever is sits in front of ingress in this cluster.
Yeah, that's where my IPs get routed to, because at the end of the day, I'm just routing to that load balancer with a host header, and that gets to my service. Inside of Kubernetes, nothing changes. Everything there is standard Kubernetes resources. So I do have 1 pod over here in EU West and 2 pods here in US East. So we can scale it down. I'll scale it down on the east side, and we'll see I should get traffic. My IPs and my traffic should send over to EU West as those endpoints go down, we're basically simulating cluster goes away or is not routable or whatever the case. At some point, this cluster or these endpoints aren't available. So now I should be able to get my traffic to route somewhere else. And to do that, let's watch this endpoint. Again, we're just going to curl it, failover test. Excuse me. I actually got, right now, both endpoints are down, so DNS hasn't propagated to go to the other side. And again, this is just like we were pointing out, that TTL might be a deal breaker if you actually are like, hey, this could never happen. You might want round robin. So this, in this case, is a failover situation. Cluster goes down. We need some time for DNS to actually propagate and go to the other side of saying, okay, now let's go somewhere else as the new cluster spins up. Or not spin up, but as the DNS propagates, I'll see there's my actual content. Like I got routed over to EU West 1 right here, which is great. That's exactly what I wanted. I can do it the other way. I could scale up my East cluster, scale down my West cluster, DNS will propagate, and I'll be sent to the other side. It's exactly what you want failover to do. A little clap for that. Those global routes, sometimes it's just like there's so many products and so many ways to do this, and using native Kubernetes resources and using DNS to me is kind of the simplest of all cases. Again, if you have like that TTL, how you're using DNS, there's a lot of things in play here, but I can see what's going on here. Well, it's awesome. So do you have to deploy many times as many clusters as I have? In this case, so failover isn't designed to be essentially more than 2 clusters. Like I don't have a situation where I have 3 clusters and 2 of them, are hot and 1 of them's cold or something. In this case, failover is you have 2 clusters, you're failing from one to the other. Round robin could have multiple clusters inside that endpoint, and I will just randomly pick between all of them. And as we said at the top of the show, IP-based routing to closest cluster is something that they'd like to do next.
Yeah, and just to reiterate that workloads are residing in each cluster, right? And the GSLB and the k8gb is getting deployed on each of the target cluster. So and GSLB kind. So Justin, maybe it makes sense to show the initial spec of the GSLB resource. So how it was this YAML file. So we can go through it, through the actual, like how to control the GSLB strategy creation, how to expose resource with GSLB.
It's in docs, examples.
Examples, and k8gb. Yeah, and GSLB failover, yeah, for example.
Yeah, good idea.
Yeah.
This is the spec that we use to create that failover resource. Of the only things I needed here, I mean, this is all standard. Here's my CRD, here's the host I'm using, and here's my strategy. And this is what the controller is using to update those CoreDNS records. I have a type of failover and a primary geotag of EU West 1. That was when I deployed it. In testing, I had already failed from EU West 1 to US East. So my primary had switched to US East when it failed. Now that I just failed back inside of etcd, that primary is going to fail back to, hey, you want EU West because US East failed. And so it'll automatically switch that for me. I don't need to like redeploy this. But as one side goes down, because it's a failover strategy, the controller can actually update those resources for me.
Yeah, and as you can notice, the ingress spec is kind of embedded into GSLB spec, right? So it's like one-to-one in underlying. It's exactly the same Golang type of ingress composed with a strategy chunk. So k8gb controller will create an ingress for you, and will compose the DNS responses according to the strategy. We also support after some feedback from our teams and actually external users, we support a way to create a k8gb annotations on existing ingress. So k8gb controller will react to that, and it will create GSLB resource automatically and kind of close the loop.
That's cool.
Yeah.
Is that based on annotations on the ingress itself?
On the ingress itself. So
you wouldn't have to manually deploy this piece. You could say, hey, I have these annotations. Controller, also make me the global load balancer for it.
Exactly. So it's pretty common situation when teams already have a deployment Helm charts, ingresses are already there, right? So instead of dropping in additional GSLB resource, it's very convenient to just extend the ingress spec with a couple of annotations. So, and it also actually solved for us like just as an additional bonus. So when you introduce a new kind, clusters, and we running more than 120 clusters, right? With pretty huge scale. We need to modify airbag rules, right? So whenever we introduce k8gb, we need to allow teams to be able to modify this GSLB resource. But with the annotation trick, we don't have to, because controller will create this resource, and teams are exposed still to good old standard ingress.
Yeah, that's actually really big. Just being able to thinking of how you manage those resources at a certain scale with either a lot of people or a lot of teams or a lot of clusters is going to get really confusing and pretty easy to mess up. It's just like, oh, I forgot to give you permission to that one thing. So yeah, for sure. And also looking, this is the other spec for the round robin entry. As you can see, I had the round robin test. And then these are basically the strategies around it. Can you explain the split brain threshold?
Yeah, it's actually something that we have implemented not in every, not for every DNS provider. But the idea is that to handle a split brain situation when like two clusters have a network partition between them, and they continuously sync in state, right? Polling each other over special service FQDNs, getting the healthy records out of each other, and then composing the resource, the final DNS endpoint CRD and eventually DNS response. So in a situation when there is a network partition between the clusters, like horizontally, they about to check the special TXT record representing that like keep alive status, kind of heartbeat of a neighbor cluster. So, and there is like a threshold of 5 minutes by default. So if this special TXT timestamp, which resides in this edge DNS and route, for example, if it's like stale, if it's the timestamp is older than 5 minutes, then this cluster is treated like a totally down, dead cluster, and it will be excluded from zone delegation. That's the idea.
Right. So if a cluster is unavailable for 5 minutes, don't ever route anything over there. And the healthy cluster, whichever cluster is updating your external DNS is the one that says, okay, all the records are mine now because I haven't seen the other cluster for 5 minutes. So yeah, that makes sense.
Yeah, and it's also the situation like it's not just like relying on a horizontal, like it can be some like temporarily outage, right? So or no ability to resolve the other cluster special DNS FQDN. So this is like additional check. Like if it's still alive, it will probably update this special TXT resource with a heartbeat. So they will not be competing for the resources. Yeah, for the
if the cluster that was down comes back, it starts updating records, you're fine. Like it just starts updating and both clusters say, okay, yeah, I see these updates. So now the cluster's back.
And then they are getting synced up and like and return a consistent response from both of the clusters. Yeah.
Yeah, that makes sense. I wonder, I do want to try, let's see if my round robin works. Cause again, I had some problems with it earlier of, it's picking random IPs, and I had less IPs exposed in one cluster versus the other. So I'm not actually sure if this is going to be working most likely it's my fault because I was messing around with it too much. But at some point, hopefully this message of EU West 1 will flip to the US West, although I could probably update or make this go faster, and I should get more. Let's see. Let's just see if it works, because it's going to do requests every half seconds. And I had so many times that, like, again, troubleshooting DNS, we cache it so many places that, like, my browser was caching it, my OS was caching it, my home network was caching it. And I was like, I don't know if this is actually true of where I'm doing this lookup anymore. It should constantly the TTL was 30. So like 30 seconds refresh and get new endpoints, but it's probably something I did here. If it doesn't work, that's fine. Oh, yes, there it is.
Yeah.
So there's our actual round robin of, hey, I have it deployed in 2 places. Please just, find the best one. And right now you can see it switching between the 2 pods in US East. It's getting both IPs. You can see the FGG and 5T. So it's failing back, or not failing back and forth, but just round robbing between those pods based on the ingress controller doing its own round robin. So we're doing a cluster-wide round robin. We switch back to EU. And then inside the cluster itself, ingress controller is doing round robin. I just feel like there's so many Robins out there that are dizzy. If their name's Robin, like constantly spinning. I don't know. It's a bad joke. I'm sorry. I guess good enough time as any to to conclude on what we were saying. So let's see. Let me pull this back. And Brent, I'm always bad at doing these. Wait, I can get it. Yes. See, I got the couch back. It always takes me a minute. But yeah, so anyone that's out there watching, if you are interested in a DNS only Kubernetes native global load balancing, I think k8gb has a really cool, just like way you can visualize it, way you can work with it, and native to Kubernetes. So it's not a third party, but it also, because you're using external DNS, it can use any provider that external DNS works with. So it creates those NS records and then it routes internally. So if you have on-prem clusters, if you have AWS, whatever the case may be, external DNS can put those records out there and you route locally and you're good. And so it works for anyone with Kubernetes in multiple places, so long as you can do some things like equal deployments or failover timeouts or whatever your use case is, fits in this model. What other DNS? I think you're talking about external DNS specifically, and so that's external DNS as a controller in Kubernetes has a handful of different providers that it can send records to, and k8gb isn't changing that at all. So it's just anything that external DNS can update. All it needs to do is basically make the delegated namespace to point to one of the GSLB load balancers. And at that point, you're good.
Yeah, but just to mention some bit of realities there, unfortunately, in external DNS providers, the quality of a provider and like coverage of an API provider like heavily deviate from sub-project to sub-project. So for example, in the info blocks, we had to create a lot of manually crafted API calls because NS records are totally, and TXT records are totally not covered by external DNS providers. So that's one of them. It's actually was like even special to info blocks API structure. So it was tricky there. In case of Route 53 and NS1, it was very consistent because both of external DNS providers like equal good quality and equal good coverage. But yeah, very optimistic scenario is that you just pick the external DNS provider, it will work. But in reality, it might not be the case, just to warn you there.
Great call out. Yeah, I mean, I don't have any experience outside of Route 53 at this point. So for sure, if there are some gaps there, that's good to know. So that's all I wanted to show off. I think it's a great, Brent was pointing out, it seems to make this DR much easier. And I agree, depending on how much, like if you can have that 30-second gap, depending on how you're deploying your clusters, I think k8gb could be a great fit for a lot of people that just say, I want HA clusters, and I want my DR to be easy. You can deploy to both places. If you want to do round robin and maybe lower some resources between the clusters, that's a possibility. But if you just want to deploy to both and make it safe to route traffic on either end, and it doesn't have to be everything, you can deploy just some things one or another. So I think that's a great option. So Yuri, thanks so much for joining us today. And thanks everyone for watching. And if you have any questions, feel free to hit us up online. We're both on Twitter, and we'll see you next time.
Thanks a lot. It was fun.
Thanks.
Cheers.